Thanks for the opportunity to be here. And I first just want to start by saying thank you to DDN. It's a great event. I appreciate the get together. I really appreciate all the Jans at DDN. I could just say Jan. And Manutius' help. He gets the joke. And James, of course, for all their help, because it's been a really big hit at the FMI, what we're doing. It's a real paradigm shift for us. That being said, I had to preface that, I'm not going to show any graphs of performance. I'm going to talk about solutions we've done and problems we face. And I assume they're problems that you're all facing too. It's not a bash at DDN, but I'm just throwing it out there, kind of the issues we're facing. Because we all know DDN's fast. We've just had an hour and a half of that. So let's talk about real life issues. So alternate titles I considered is moving sucks, okay? Because that's like, because we're migrating now from SAMFS to DDN. Anytime you shift a storage system, it's just a drag. The other title I considered was biologists are not physicists, because you have to be make it really easy for them. They want a GUI, they want a web front end, or help, because all the challenges that we still face of backup, disaster recovery, and things like that. So I put a legend on every slide so you can understand where the status of it is. I don't want to say that these things are done or whatever, but then you kind of have a context. So production means we're doing this. Migration means we're moving it. We have to migrate from SAMFS over to GPFS. And under construction means it's a new tool that we're going to be developing. So FMI is a research institute in Basel, Switzerland. Biomedical research has existed for about 40 years, over 40 years. It's funded by Novartis. It's a great place. We work with a lot of core technologies. And it's great because we really see them every day. We're all in the same building. So it's a lot of fun. It's a great environment to work in. So I thought, I didn't want to show any slides of gear, but I thought I better because then you at least know what the hell I got. So we have a DDN GS14KX and a DDN GS7KX. And what we do that's really unique, pointer is, so of course they have a lot of laptops. So we really make this the whole back end of everything. The goal was just make everything fast. That was the focus. So we put, all the laptops have access to it. All the desktops have access to it. The instruments have access to it. And what we've done is we built like a scientific computing environment on VMware. And we make like 88 core VMs and with a terabyte of RAM just for fun because that's what they need sometimes. So, and then other things we send out to a cluster, but we use a cluster over at Novartis for that stuff. But we have a very heterogeneous environment, very strange applications they want to use. And instead of us spending the effort to port it, we just make it bigger, fast for them. And then basically we have a DDN in one data center. We have a DDN in a second data center we replicate to with our sync. And then we have an offsite. We haven't implemented yet with the backup, but we have an offsite tape archive system that we sync files over into. But directly we basically move or copy them over there. So that just indicates that's our. So the workflow overview is, basically again, the data is coming into from the instrument here. We have the VMware environment. So we really are trying to move to heavily virtualized environment. And then, they kick the data here, then they do the post-processing here, and then they access and look at the pretty pictures, I call it, from their laptops. And then when the data gets old, we migrate it out. So, nothing that you all don't know, but just to say it again is really, our goal is to get old data off the system or into the least expensive media as possible. So you have the meta results, the analysis results, and everything else can just be moved off the disk as fast as possible or into a lower cost area, obviously. And I'm sorry, these slides you can't read, but you get a copy of the slides. But we've really analyzed the workflows from, so again, it's a very heterogeneous environment. We have like over 100 instruments in the Institute, producing anywhere from 10 terabytes a run to just a few gigabytes. But what we find is the large data processes, which I'll show you in a second, it was a bit easier to read than this, is they're almost all the same. And even though you're on a confocal or high content screening or electron microscope, the workflows are almost identical. So we've been focused on optimizing those. So again, a little bit easier picture to see. We basically you do your acquisition, we do it directly. Well, you'll see another slide in a second explain this more closely, but basically it's going to go into the scratch. Then the people, or we send a second copy to a local NAS on the box or the instrument if it's a really large amount of data, because it's cheap, and then we also directly attach it, so there's a network problem, it's not an issue. And then we can copy that into an archive directly. Then let me see, where's 2, 3, 3. And then they're going to do some image compression or post-processing on it. Ideally send off the raw data to tape, and then basically do some more work on it for a longer time on the analysis of it. And then they're going to store the results into the group area. So this is one of our instruments. This is one of our more challenging ones. So this is what's called high content screening. So this is the one that can produce anywhere from 5 terabytes to 10, just depending on what button you push. And some of their data, the complete data set can be about 100 terabytes for a big screen. So this is the technique that we developed. I call it same-day analysis is the goal. Because our goal is that they can be doing their work as fast as possible. This is completely not supported by any instrument vendor, and they'll tell you not to do this, but we found it works. So what we do in the instruments is we put as much internal SSDs as we can. So we put some 10 terabytes of SSD into them. And then while they're acquiring, this is the part that's not supported, is that we actually copy a copy out to the cluster, and we copy a copy out to the NAS archive at the same time. Because usually what was, and then they could, if they're lucky and their stuff can be done this way, we can already start post-processing that data before they even finished running the experiment. So ideally, by the time they are walking away from the instrument, going up to their office, they've already copied it off and they've already started the archiving process, or they've already done post-processing it. Because often what was happening before is they would finish the experiment, then they would drag the files over, which would take another, that experiment could take 6 hours. They would copy it for 3 or 4 hours, even on a 10 gig link, and then they would start processing, which is just silly. So this is quite nice. And we've not just done it for HCS, we've also done it for behavioral studies and a few other areas, and they really, really enjoy it. And then this is if you want more, if you want the tool that we developed for this, I'm happy to give you this. I mean, it's nothing fancy. It's embarrassing to even say DDN and robocopy in the same sentence, but it actually works surprisingly well. So then another tool that we set up is like an Sftp request system for users, because again, we have people that want to transfer large data sets out. So we allow a full self-service process for them to request an Sftp account for users. Because a lot of these other tools, they really can't deal with these large data sets. So again, if somebody's interested in how we did that, I'm happy to give the code or to explain how we did this. So the users just go to a website and they fill in their information, and then they get an email for a 4-week Sftp account. They give it to the person, they transfer the data up, and it's very simple. Then this is the account creation email, and then so that, like I said, these are all things that are done. So the moving part. So this is how we developed a tool with a person named Tobias Oedeker to do called DU2RID. You can download this. You can Google it. It's open source, and that walks our SAMFS file systems and produces these nice graphs. And then, but now we have to get this over to. So it's a bit of a drag. So we also have a nice tool that we developed for quota management. For home directories, group directories. So it's all one GUI, so we can go in there and then increase people's quotas. But again, we got to move it over, so it's a bit of a drag. We're in this process right now. We've had the system since January. I mean, it's running, it's productive, people are doing data, and we're doing, like the big users have moved over, but we have a lot of work to do to get it up fully. So a quite cool tool that we developed, because a lot of people will email their users, say, you've reached your quota. Have a nice day. No other information at all. And the users are like, what am I going to do? So what we've done is we developed a tool that actually will email them that and email them the link, and they can click on the link and they can drill down a little bit to see which data of theirs is hot, which data of theirs is cold, and then they'll send an email. I mean, we even say very nicely in the email, you can either, archive it, or you can actually ask us to increase it. But actually very nicely, a lot of users will actually go look at this, and then they'll tell us what data that we can archive. Because we don't have an automated process for that yet. So again, we have to move all that over. So now this is a project that we just started, and I hope somebody can tell me there's already something like this out there, is that we've been requested to develop a generic, because again, it's a very heterogeneous environment, so we cannot generalize too much like this, or let's say have one solution for everything, and the users interacting with an HSM file system or dragging 5 terabytes over to an archive is just not, okay, and as I said, they're biologists. There's a reason they went into biology. Their strength is not computer science. That's the joke, okay? But then again, that's quite important these days in biology. So we're now developing a general archiving process with a web front end for the users. And actually what we're going to do, so we're also doing this with Tobias Oederker, and then we're going to open source it. And then we're going to actually, the idea is to put all those other tools that I've shown you into that, and then try to provide it as a virtual machine that you can plug into your environment. You know, again, try to, in an open way, so nobody else has to go through the pain that we just went through, and maybe you can have some nice tools, and we could work with some other people and add nice features to it. And that's part of what we do at the FMI, is we try to make science better. That's why, and all these other activities. So that's the generic overview of the workflow. So they'll have emails, approvals by the group leaders, and things like that when they're archiving. So they can also put metadata on it, and they can find it back later on and pull it back off tape or wherever they archived it. So backup. Okay, you know, as I say, you know, TSM offers incremental forever, restore forever, right? Is that what it's called? Because you can never bring, honestly, I don't think there's a valid backup strategy of any GPFS file system that would really actually be viable to bring it back. AFM terrifies me from everything I've heard. So really we're still have not implemented the backup. So we're trying to do that. We do an rsync process. Oops. We do an rsync process now. So we've parallelized that. But you know, we looked at AFM. I brought an expert. In order to make decisions about GPFS and TSM, I had to bring 4 experts into the room to discuss it in order to come to one conclusion of what to be done, because there's so many different ways of doing it, and whether it's the best or not is it's quite a question. So that the rsync seems to work quite well, but I just still don't feel like very confident. I mean, I really miss my SAMFS from the context of the security and how simple it was to manage, but I don't miss it for the performance, because it's great. GPFS and DDN is fantastic. It's amazing what we can do, but we have a long way to go and to get the security so I can sleep well at night yet about our data security. I mean, we have snapshots and all these other things, but I like a lot more with SAMFS. I could restore and dump the metadata every night and dump and onto another location, and then I knew I could recover all my data, and I can't do that with GPFS. So right now we're discussing, so we've bought TSM, we're just trying to determine if we can get out of using it, and maybe have a different approach here. So that's our weak link at the moment. So I'm happy if anybody has suggestions on this. A nice tool we had in SAMFS is we had a GUI Front-End, so these are for the non-admins, like the IT support, things like that, to restore data, but it would troll back through the snapshots and then allow somebody to put back a snapshot onto a file or file system. Or actually what it did was it would just go through the tape recycling, because if you delete something on tape, you delete something even in a GPFS file system, the data is still there if it's not been cleaned up yet, so if it hasn't been reclaimed. So this is quite a nice feature that we had in SAMFS. So, you know, we'd like to move or find a tool that we could do this as well with the users. And then what we do, again, this sleep at night factor. So one time I had a sysadmin in my team, and he went on vacation for a couple weeks. So then I had to monitor the backups. And I noticed that he was missing 1/3 of the machines and the backups for months. So after that, needless to say, it doesn't work for me anymore. What we did is we developed a daily process that goes back and makes sure that all of our VMs are backed up, that it even checks against the VMs against the VM backups. We check the SAMFS, we check the tapes, we run the restores every night of the metadata. And that's consolidated into one report that 2 systems administrators have to co-sign, that everything is okay, and that if there's any remediation to any tasks, that they mention the remediation that they've done on the task. So hopefully everything, you know, it'll tell you if there's outdated backup issues, it's all at the top, and then it'll give you the report at the bottom. So again, we have to move that over, we have to implement that into our DDN system. So conclusion is, moving sucks. It's a pity there's so much real reinvention in this space. I'm not bashing DDN. Please don't take that wrong. As I say, because it's luster, a lot of other things. But it'd be great to work together. It'd be great if IBM provided better tools. There's so many little tiny gaps in GPFS, like SOBAR and some other ones that are really useful, but not quite usable. Biologists are not physicists, so we really have a lot of work to do to help them to simplify using the system, because they're not doing code, they just want to get their data from a SIF share or something like that. We're happy to work with other people. And like I said, it would be nice if there's these kinds of tools generally available for large data management. It's very useful, practical. So that's